Okay, it's on to lesson 14. This is finding solutions to inequalities in context. And remember, in context means we're just going to start looking at inequalities in relatable situations in real life where we might come across something like this. We're still going to be dealing with those symbols that we've been using for inequalities, the greater than, less than, and then writing inequalities. So let's look at the warm-up question here, the first question. It wants us to find two solutions to the inequality that's listed. We've got two of them here. If you look at the first one, we have a value for x, so we need to put a solution in for. Now, because it's an inequality, there's going to be many solutions to it. We just need a quantity that's going to be larger than 10. But there's a negative sign in front of our x. So whatever we call our value for x, it's going to be, I think the best way to think of this is to be thought of as the opposite of it. Okay, we could say numbers like 3 and -3 are opposites because they're both equally distant away from 0. So that's kind of how this is going to work. Whatever we call x, it's going to become the opposite. What I mean by that is if I say x is 2, okay, now the opposite of 2, because of this negative sign, is -2. -2 is not bigger than 10. That wouldn't be a solution for x. All right? So we need to think about that. If we get bigger with our number, if we say 20, 20, but the opposite of 20 is -20, that's not bigger than 10 either. So we need to do something else because getting larger in the positive direction is not working. Let's try the negative direction. If I were to try x is equal to -1, the opposite of -1 is +1, and that's still not greater than 10. So that's not a large enough, or that's not, we need a different negative number to make that work. Okay, a smaller negative number. So let's try 20 again. If I say -20, x is equal to -20, the opposite of -20 is +20, that is greater than 10, so that would work. That would be a solution for this. X can equal -20, and be sure to put the negative sign because that's very important. When we find the opposite of it, this becomes +20 here in the inequality. Go ahead and put down another solution to this, and then we'll do the next one. Okay, for the next one, we have 2x's is greater than -20. Whatever my x value is going to get multiplied by 2 to be larger than -20. Well, I can see that I think just about any positive number is going to work here. If I say x is equal to 5, 5 is going to get multiplied by 2. Keep this as a positive number, so that'd be 10. And 10 is certainly greater than -20. All right, now there's got to be some negative options that could possibly work too. Think about that, and why don't you find a negative value for x that would make this inequality true. All right, hopefully what you found is that -1 would work because we're taking -1 times 2, that's a -2. That's still closer to 0 than -20, so it has a greater value, so that would be true. -1, -2 would work. Let's think of what the smallest negative number would be that we could put here. So 2 and 10 make 20, so that's where I'm going to start. If I put -10 here, -10 times 2 is -20, and that's not greater than -20, so that wouldn't work. I'd have to go back closer to 0, so the smallest negative number is going to be -9 as a possibility. So if you had anything between -1 and -9, as long as you did a integer, a whole number, that would certainly work. Okay, Now, let's talk about how we take these contexts, these situations, and we apply an inequality to it. So this is going to build up to that for us. It says Andre has a summer job selling magazine subscriptions. He earns $25 per week plus $3 for every subscription he sells. Hopefully, you're thinking back to our unit where we talked about percentages, because this is a commission. Usually, we would give a percentage for what he sold. This case, he's getting exactly $3 for every subscription. Andre hopes to make at least enough money this week to buy a new pair of soccer cleats. All right, so he's got $25 per week coming in, $3 for every subscription he sells, and then I would say making at least enough money is key to what we're going to be doing here, so he can buy a new pair of soccer cleats. Part A, let N represent the number of magazine subscriptions Andre sells this week. Write an expression for the amount of money he makes this week. All right, expression, not equation. So we're not going to have an equal sign in this. We're just going to show what he's earning. So we know right away he's going to get paid $25 for working that week. Then he's going to make $3 for every subscription, and we're going to use N to represent the number of subscriptions. So let's think, how would we increase the amount of subscriptions, $3 for each of them? Well, since we don't know how many subscriptions it is, we couldn't just write plus 3, plus 3, plus 3, plus 3, because we wouldn't know how many 3's to write. Let's go to multiplication. We will add, multiplication, meaning we're going to take $3 times the number of subscriptions that he sells, N. And then since we're talking about what he's earning, his paycheck, that's all going to be combined into his paycheck. So we're going to add those two quantities together. There would be our expression. Let's look at part B. The least expensive pair of cleats Andre wants costs $68. Write and solve an equation to find out how many magazine subscriptions Andre needs to sell to buy the cleats. So we're going to take what he's earning, turn that into an equation. We want it to equal $68 because that's the money he needs. And then we'll solve it. So keep in mind when we're solving these equations, we want to do the inverse operation or the inverse of something and then balance it on both sides. So let's get rid of this $25 we know he's going to make that week. Let's subtract 25 and balance it on this side. That's going to leave us with 3n equals 43. Then let's divide by 3 so we can get n isolated here. Divide by 3, divide by 3, and I'll write my answer over here. So n equals about 14.3. Okay, we'll just round that. Now, let's go back to what we're finding here, what we're answering. This is the number of magazine subscriptions Andre needs to sell to buy the cleats. He needs to sell 14.3 subscriptions. Now, that's not a great answer. This is how you'd solve the equation, and we could give this answer as a fraction, but you're not going to be able to sell a part of a subscription. So truly, we need to decide what whole number of subscriptions he needs to sell in order to buy those cleats. If he sold 14, if we rounded this to the nearest whole number, that wouldn't give him enough money because we're taking away some of the earnings, some of the profits that he's making. So that wouldn't work. We need to round up to the next subscription. So really we would say he needs to sell 15 subscriptions to buy those cleats. That's a much more realistic answer to this question. And the next part says, if Andre sold 16 magazine subscriptions this week, would he reach his goal? Well, if 15 is going to help him reach his goal, 16 is just going to provide extra money. So, of course, that would work. Lastly, write an inequality expressing what Andre wants to make, expressing that Andre wants to make at least $68. All right, so notice how we've progressed here. We started with our expression. It was very easy to make an equation just by making this earnings expression equal what he needs to make. Now we're going to take this and we're going to make it an inequality. So we're going to get rid of that equals sign and we're going to put an inequality symbol in there. So if I have 25 plus 3n and then it was equal to 68, now we're going to put an inequality symbol here. So this represents his paycheck, what he earns. This represents what he needs. Do we want his earnings to be more or less than the amount of money that's needed? Well, of course, we want it to be greater than what he needs to earn. If he needs $68 but he earns more, that's fantastic. If it was the other way, if it was less than, that would be a problem because he earned less than what was needed. And let's ask ourselves, can it equal? Well, yes, it can. He can equal exactly $68 with his paycheck, and he's good to go, even though we said it would take a weird number of subscriptions to do that. Okay, go ahead and turn to the back side of your packet now. Let's look at this next example. Diego has budgeted $35 for his summer job earnings to buy shorts and socks for soccer. He needs 5 pairs of socks and a pair of shorts. The socks cost different amounts in different stores. The shorts he wants cost $19.95. All right, I think this is going to kind of work us through again, going from expression to equation to inequality. So part A says, let X represent the price of 1 pair of socks. Write an expression for the total cost of the socks and shorts. Okay, total cost of the socks and shorts. We need to go back and find that information. He budgeted $35 to buy that. That's the amount of money that he's got set aside. He needs 5 pairs of socks and a pair of shorts, 1 pair of shorts. The socks are different amounts. That's why we're using X here to represent the price of a pair of socks. The shorts he wants cost $19.95, so we have that price. All right, write an expression for the total cost of the socks and shorts. So we know he needs 5 pairs of socks, but we don't know what they cost. So whatever that amount is, that's the price of a pair of socks, we need it 5 times, 5x. Then we need to include the cost of the shorts, which is a set price. He wants the $19.95 shorts. And that would represent adding up the 5 pairs of socks and the cost of the shorts. That would be our expression. Now we're going to make an equation so that he spends exactly $35 on these 2 things because that was what he had budgeted. All we're going to do is write that expression and make it into an equation and then solve it. Remember, we need to do the inverse operation and balance it, so we'll subtract $19.95 from both sides, and then whatever we have remaining, we will divide by 5. So after you do all of that, X, which again is the price of the socks, equals about $3.01. I'm going to put a dollar sign there because we know we're talking about the price of the socks here. Now, list some other possible prices for the socks that would still allow Diego to stay within his budget. He budgeted $35. We just solved this equation to find the price of the socks. Now, let's think about that. If he can afford socks that cost $3.01, then could he afford $4 socks? Well, that would set him over his budget because he's paying more per sock than what he's able to. We want to go less than that. So some other possible prices, well, he could pay exactly $3. or $2 or $2.50 or a million other possibilities. Okay? And then lastly, write an inequality to represent the amount Diego can spend on a single pair of socks. So we don't necessarily have to turn our equation, well, we could write our equation as an inequality, write an inequality of the amount. Okay, I think what we need is just a statement that's going to represent all these possible sock prices. Okay, so our equation helped us find that top price, the most expensive that he could spend on socks was $3.01. Anything less than that is going to be fine. So we want to say that the price of his socks has to be less than or equal to the top price he can pay on socks, $3.01. All right. Now, we're going to take a look at something very important with inequalities. We're going to be talking a little more about this soon, but let's take a look at this first example and try to get some clarity here. So, Kieran has $100 saved in a bank account. The account doesn't earn interest. He asked Claire to help him figure out how much he could take out each month if he needs to have at least $25 in his account a year from now. Claire wrote the inequality for him, where X represents the amount Kieran takes out each month. Solve the inequality. Okay, so let's look at this quickly. We've got negative 12x. Negative 12 must represent the months of the year, 12 months in a year, and it's negative because this is going to be a negative amount being removed from his account. We're going to remove that negative amount or combine it with the $100 that's there. We just have to keep it above or equal to $25. Okay? So if you think back to the other examples that we did, we can solve this like an equation and then use our inequality symbol at the end to represent the possible answers for X. So let me try to fit this here. Negative 12x plus 100. I'm just going to write this, well, I'm going to keep my inequality symbol because I don't want to forget about it, but I'm going to think of it as an equal sign and think of this as an equation. So I'm going to do the inverse. I'm going to subtract 100 from both sides. That's going to leave me with negative 12x and negative 75. When I subtract 100 from 25, I'm at negative 75. Now I'm going to divide that out by negative 12 to cancel that. And x is going to be negative 75, excuse me, divided by negative 12, which is 625. Okay, now here's the thing that I really need to think about. So if x were to equal 625, that means he could take $6.25 out of his account each month. And that should work. That will still leave him with $25 in his account at the end of the year. But if he were to take out less than that, he would have more than $25 in his account at the end of the year, which is still a good thing. So normally we would say, well, this is the greater than or equal to sign that was in our inequality, so I would put greater than or equal to here. Greater than or equal, just like it was up here. But in the context of our problem, if Kieran takes out more than 625, that's not going to work out. He won't have $25 remaining in his account anymore, and that won't work. So what we actually have to do in thinking about our answer is think logically that what he needs to take out can equal 625 or less than that. He can take out less than 625 each month and still have that minimum $25. So notice how that symbol switched, and it's switched based on the context of the situation here. So let's look at another one here. A teacher wants to buy 9 boxes of granola bars for a school trip. Each box usually costs $7, but many grocery stores are having a sale this week. Different stores sell the boxes of granola bars at different discounts. If X represents the dollar amount of the discount, then the amount the teacher will pay can be expressed as 9 parentheses 7 minus 6. In this expression, what does the quantity 7 minus 6 represent? Well, I can see 9 refers to the 9 boxes of granola bars that are needed. Each box usually costs $7, and then it said that there's different discounts. If X represents the dollar amount of the discount. So, what does 7 minus 6 represent? 7 minus 6 is the price of the granola bars minus the discount, whatever it is at each store. And then it's, of course, being multiplied by 9 because she's buying 9 boxes. Okay? So let's write down, what does 7 minus X represent? It's the cost after discount. Then, the teacher does not have to spend all $36. Does not have to spend all $36. Write an inequality relating 36 and our expression from before to represent the situation. Okay, so we will take this expression, because that was the cost of 9 boxes of granola bars after the discount. We're going to relate it to 36. And remember, it said the teacher does not have to spend all $36. So, do we want the cost of the boxes of granola bars to be larger or smaller than $36? We want it to be smaller, if possible, because then she's not spending all of her budget, or it could equal 36 if it had to. The last part says the solution to this inequality must look either like this or this. X is greater than or equal to 3, or X is less than or equal to 3. Which do you think? So what it's saying is, if we took this inequality like we did up here and we solved it, we got all the way down to the bottom, we found that X was equal to 3. Okay, solving it like an equation. Now, do we want X to be less than 3 or greater than 3? We know both options that can equal 3, so that bar is going to be there. Let's figure out what X is first. So remember, if we go back to the situation, X represents the dollar amount of the discount. X is what's being taken off of the price of each box of granola bars. So if we have to keep this under a budget, if we have to spend less than $36 or equal to $36, the bigger the discount on the granola bars, the better. If the discount is $3 off of each box, that works. It equals out and she spends 36 bucks. But if the discount is more than $3, that's great. She's saving money, spending less than 36, and that's what we would need here. So notice how our symbol changed again. It reversed in this. All right, we're going to talk more about this in the future, but you have to be aware of the context to see if we should reverse this inequality symbol like we did in these two examples, or if it should stay the same. And sometimes it will stay the same as well. We're going to talk more about this heading forward. Please take a look at your practice problems. And of course, I am happy to help on Zoom. Have a great day.